Good morning, students. Today I am going to start the next topic, dynamic programming algorithm. Okay, so it is one of the strategy to solving the problem. So dynamic programming is a strategy to solving the problem. So dynamic programming is also similar to greedy method algorithm. Okay, just recall about what is the concept occur in greedy method algorithm. So there is feasible solution. That means a problem break up into more than one sub problems. Then after to find more than one solution corresponding of that problem, then after to calculate, then to find the feasible solutions, then next we want to get the optimal solution. So that process is called optimization. Okay, so the same concept is done in dynamic programming is also. Okay, so dynamic programming and greedy methods are also similar to satisfy these concepts. Okay, so actually what is the difference between both of them? So dynamic programming to follows the optimality, that means the principle of optimality. So actually what do you mean by optimality? So the optimality says that means it takes a sequence of decision making. That means a problem break up into more than one sub problems. So each and every stages it must take the decision. That means more than one. Otherwise sequence of decision of every stages of solution. Okay, so that is the difference between dynamic programming algorithm and greedy method algorithm. Once again, I repeat this concept. In greedy method, the solution must satisfy particular criteria. Okay, then only we can get the main solution of the problem from the greedy method. But dynamic programming algorithm, here is also the main problem break up into sub problems. That means it is a followed by recursion. Then each and every sub problems to find the corresponding solution. Okay, then how can get this solution? The solution must satisfy the condition. That means to make the decision of every stages of solutions. So that is the difference between dynamic programming and greedy method. Okay, so that is the main concept. It is the principles of optimality. Okay, then here listen the points about dynamic programming. So dynamic programming is mainly an optimization over plain recursion. Wherever we see a recursive solution that has a repeated calls for same inputs, we can optimize it using dynamic programming. Okay, so what do you understand about this concept here? Then so it is the optimization process. Okay, optimization process means as usual main problem break up into large number of sub problems are there. So that is the based on recursion. That means recursion means again and again. Okay, repeated again and again. Then how? That means to use the same parameters. That means same input. Okay, same input and same call, function call. Okay, the same function calls and the same inputs repeat again and again. Okay, so that is the optimality in dynamic programming. Okay, then so in this algorithm following four otherwise or some of the steps to following to solve the problems. Okay, so what is that? First one is breaks down the complex problem into simpler problem. Okay, otherwise simpler or sub problems. Okay, breaks down complex problems. Okay, say biggest problems is divided, otherwise breaks into simpler problems. Then after optimal solution to these sub problems. Okay, then can you remember that diagram? Okay, then sub problems, that means each and every sub problems, okay, then can carry solutions. So actually what type of solution is there? That is the optimal solution. Okay, optimal solution means what? Then to find two or more, otherwise to find then more than one solutions are there. Then after to analyze which solutions are satisfied that criteria. Okay, sometimes two solutions are satisfied that criteria. We want to select that two solutions are called feasible solution. Then after to take the decision which one is the optimal solution. That means the accurate solution. Accurate solution means we want to select only one solution. So that is the final solution. So that solution is called optimal solution. Okay. So find optimal solution to these subproblems. Then after what? Then if you get the optimal solution, that solution is stored in somewhere. Okay, store the results of subproblems. Okay, so if you get the optimal solution, so that solution is called result. So that result is stored. Okay, store from somewhere, that means some problems, subproblems. So that method is called memorization. Okay, if you get the optimal solution, so that solution is stored into subproblems. So that process is called memorization. Then afterward, then reuse them. Okay, again reuse them so that the same subproblem is not calculated more than once. Okay, so what is the concept? Here is the same problem or the same function call and same input are again and again using here. So that is the limitation. But in memorization method, then reuse the same, otherwise the result from the subproblem is not calculated more than one. That means what? So that result is only once. Okay, we need to use only once. It cannot be repeated. Okay, because if you repeated the calculation, we have loss of time, then we have to do more task. So that is a maximization. So this concept is now needed to in this programming. Okay, so if you get the result, so that result use only once. So that is you get the time limit and you have less job, okay, or less task. So that is the main thing. Okay, I think you can understand that point. Okay, then if you get the optimal solution, that solution is stored into subproblems. So that solution we can use only one time. It cannot be calculated more than once. Okay, then after finally calculate the result of complex problem. Okay, then after to get the optimal solution, that solution can be used only once. So that solution is the solution of complex problem. Okay, can you understand this concept about dynamic programming? I think you can understand. The next point, what are the elements used to dynamic programming? Okay, dynamic programming used to solve problems with the following characteristics. Okay, so here to specify the characteristics, that the same concept or the same function about the dynamic programming. Okay, first simple subproblems. Okay, so actually what is subproblems? As usual, we should be able to break the original problem to smaller subproblems that have the same structure, because every problems, that all problems can following the same structure. Okay, so the next one is optimal substructure of the problems. Optimal, that means the result. Okay, the optimal solution to the problem contains within optimal solution to its subproblems. That means what? Optimal substructure mean? That means to find the optimal solution of every subproblems. Okay, that means every subproblems can following solution, that is a optimal solution. Okay, then after the third point of the characteristic is overlapping subproblems. Overlapping means what? Then more than one subproblems. Solutions are there. Okay, so there exist some places where we solve the same subproblem more than once. Okay, that means the same function call and the same parameters repeat again and again. So that is overlapping. Okay, overlapping, that is overlapping. So these are the three elements used in dynamic programming. First one is simple subproblem, then after to corresponding optimal solution, then it can hold a substructure. Okay, then after overlapping of its subproblems, that means the same function call repeat recursively. Actually, if it is recursive terms are there, automatically overlapping is occur there. So that is the overlapping concept. Okay, then